What is an inverse function? Well, let's first review what a function is. A function is just a rule where, starting with any input, you plug it into the rule and you produce an output. Every input determines an output. A function is a rule where you start with an input, you stick it into the rule, and you get an output. The inverse function starts with your old output and it produces the original input. So the inverse goes the opposite direction. To see both of those in the same picture, if we have a function f starts with an x and produces a y. What the inverse does is it starts with the output y and it produces the x. So f starts with x and gives you y. The inverse starts with y and gives you x. Okay, so let's do an example of a particular function. Consider the function f of x equals x plus 3. Notice this is not multiplication, even though I used the word of and even though this looks like multiplication. We could write f as f of t equals t plus 3. This same f could be written as f of z equals z plus 3. This same function f can be written as f of blah equals blah plus 3. Every single one of these are saying the same exact thing. Okay, so let's look a little bit more at what f is. F starts with an input x over here, and then you get a x plus 3 right here. So starting with a -2, when you add 3, you get 1. Starting with -1, if you add 3, you get 2. So f starts with an x and produces a y. You start with a number and you just add 3 to it. That's the function f. The inverse of f is f inverse. This -1 up there is not an exponent, even though it looks like an exponent. You read this as f inverse. So the inverse of f of x equals x plus 3 is the function f inverse of y equals y minus 3. These do the exact opposite things. Many people write the function f inverse of y equals y is 3 instead like this. They'll write f inverse of x equals x minus 3. You'll see in a moment why I prefer in some cases to leave it as a y. But these are saying the same thing. So this function f inverse starts with a y, such as 1, and then you subtract 3 to get -2. Or we can start with 2 and subtract 3 to get -1. So the relationship between f and f inverse, f is basically represented by this top equation, where f starts with the x, and this tells you how to get y, as you just add 3 to it. F inverse starts with a y and tells you how to get x. Notice that these two equations are the same exact relationship between x and y. It's just the original function f starts with the x and gives you y, and the inverse starts with the y and gives you x. Okay, let's do another example. Let's find the inverse of the function f of x equals 10x. So what's the opposite of multiplying by 10? Dividing by 10. So the inverse of multiplying by 10 is dividing by 10. So, taking a look at some inputs and outputs, if the function f has its inputs on the left side and the outputs on the right, we may start with -1 and produce -10. Or starting with 0, we get 0. F of 1 is just 10, f of 2 is just 20. Now the inverse starts with the old outputs and produces the original inputs. So if we plug in a y such as -10, then f inverse of -10 is -1. F inverse of 0 is 0. F inverse of 10 is 1. Using this right here, the inverse is just dividing by 10. Here is the key. The key to what it means for a function to be an inverse. So start with any input x. Then we apply f, then we apply f inverse, and then if you do that, you've got to end up back where you started with, x. Here is the key written algebraically. Start with an x, then you apply f, and you take the output of f and you plug that into f inverse. If you do that, you have to end up where you started with, x. Let me make a quick note that the outputs of a function f are the inputs of its inverse, if the inverse of the function even exists. And the inputs of a function f are the outputs of the inverse. Let's do one final example with an exponential function and a logarithm. Let's start with this function, f of x equals 2 to the x. I'm going to call that y. So what this function does is it starts with an exponent, say 2, and then you plug that in for x right here. 2 squared is 4. Or do another example. Let's have x be 3. 2 cubed is 8. So the function f starts with an exponent and produces a power of 2. The inverse of that is the logarithm. And what a logarithm does is it just takes a power of 2 and it says what exponent produces that. So for instance, starting with 8, the exponent of 2 that gives you 8 is 3. Or starting with 4, the exponent of 4 that gives you 4 is 2. Or starting with 16, the exponent of 2 that gives you 16 is 4, because 2 to the 4 equals 16. So here's what we have. So we have the function f right here, which is the exponential function. You plug in an exponent for 2. So you start with an x, and then you get a power of 2. What the inverse does, the logarithm, is it starts with the power of 2, and it gives you the exponent. This last description on logarithms might be difficult if you're not already comfortable with logarithms. If you aren't, I'd recommend that you watch my other videos on logarithms. Also, if you liked any of these explanations, I recommend that you check out my book, Understand Math, Reasons for the Rules. I wrote this book as a supplement for the math people learn in middle school and high school. Why are the rules of math what they are? Why are they true? Most of the rules in math aren't arbitrary at all, and I explain why they're not arbitrary in this book. Thank you for watching.